Good morning everyone. Today I Manshi Kumari from BSc Chemistry Honors final year is here to make a video for visually impaired students on the topic environmental chemistry. Environment in general comprises of first the atmosphere, second the hydrosphere, third the lithosphere and fourth the biosphere. First, atmosphere. It is the layer of gases surrounding the earth. It filters harmful radiations and allow only near UV, visible and other longer wavelength radiations to pass through it. Second, hydrosphere. It includes all type of water bodies like rivers, ponds, lakes, oceans, glaciers, polar and ice caps, etc. Third, lithosphere. It is the outer crust of Earth consisting of minerals and soil. Fourth, biosphere. It includes all living organisms and their interaction with atmosphere, hydrosphere, and lithosphere. All the constituents of environment influence one another. Environmental chemistry is a science which deals with various chemical phenomena occurring in the environment. It includes the study of sources and effects of certain specific chemical species called pollutants on air, water, and soil. By definition, pollutant is a substance produced either by a natural source or by human activity which has an adverse effect on the environment, that is, which causes environmental pollution. Environmental pollution can affect humans, animals, plants, and also materials. While it may cause illness or even death in case of humans and animals, it may reduce the growth of desirable plants and in some cases may cause them severe injury. The effect on materials includes corrosion of metals and marble as well as discoloring of paints. An idea about the adverse effect of environmental pollution can be had from the facts that nearly 4,000 persons died of respiratory diseases in London in 1852. Hundreds of Japanese suffered from disease and death on eating polluted fish from Minamata Bay during 1953 to 60. Nearly 500 Iraqis died after consuming polluted wheat in 1972 and so on. Long distance movement of pollutants. There is sufficient evidence to establish that many types of pollutants get distributed over the entire earth in short periods. Radioactive fallout from atmospheric nuclear tests conducted in any part of the world become detectable in all parts of the world within days or weeks, and from the analysis of the fallout the scientists can easily learn a great deal about the type of the tests carried out. Even the polar regions are not immune from the fallout. Chlorinated hydrocarbons such as DDT and its metabolites get distributed throughout the world, having been transported by air or by some other means not yet fully understood. Thus, DDT at the level of 100 ppb has been detected in the liver and fat of animals living in Antarctica, thousands of kilometers away from the sites where the pesticides are actually used. There is now growing evidence that many chronic diseases such as asthma, bronchitis are environmentally induced. The allergy problem being induced by Parthenium Congress grass, whose seed was inadvertently brought into the country from USA along with the imported wheat during the period in which India had a shortage of food grains, is a source of immense worry for the country. The World Health Organization has estimated that 80 to 90% of all human cancers are environmentally related or induced. The inordinate pollution growth, rapid industrialization, fast urbanization, and modified agricultural operation have intensified the interaction of man with the environment. As a result, there is alarming increase in pollution of air, water, and soil. Human health is seriously affected by environmental and ecological disorders. The situation is, if not controlled, would be a big threat to the very survival of mankind on this earth. The developed countries where the pollution problems have been more severe started taking effective remedial measures since early 60s. In 1970, they celebrated the Earth Day under the auspices of the United Nations. In 1972, the United Nations held a conference on human environment. Since then, the developing countries, including India, have also become conscious about protecting their environment. The setting up of the Central Ganga Authority for complete depollution of the Piyus Ganga water is a consequence of that very consciousness. The government of India have now a full-fledged Ministry of Environment which seriously looks after the conservation and protection of environment. Mankind is faced with several types of pollution such as air pollution, water pollution, soil pollution, thermal pollution, metal pollution, noise pollution, etc. In this chapter, we shall deal with only three types of pollution, that is air pollution, water pollution and soil pollution. Air pollution. The problem of air pollution is not a new one. It has been around for centuries. More than 3 centuries ago, John Evanlian, a noted scientist and diarist, complained about severe air pollution around London. He described with great accuracy the effect of air pollution resulting from combustion of coal. Extensive studies in this context, however, have been carried out only during the last few decades. When we talk of pollution of air, we mean generally the pollution of that part of the atmosphere which is nearest to the Earth's surface, extended to a height of about 80 km. This is known as homosphere, since it is composed of a homogeneous mixture of various constituents. The homosphere constitutes about 99.9% of the total atmosphere. Air pollutants. The air in nature is never clean. It is invariably polluted. The common gaseous pollutants are CO, CO2, SO2, H2S, NO, NO2, and common solid pollutants called particulates are carbon and dust particles, pollens, aerosols of lead, etc. The gaseous pollutants are released into the atmosphere as a result of volcanic activity, vegetation decay, forest fires, coal refuse fires, etc., natural activities, as well as by combustion of coal and oil, burning of gasoline in automobiles, agricultural and slash burning, etc., human activities. The particulates are produced by volcanic eruptions, high velocity winds, and biological processes, natural activities, as well as by smelting and mining operations, stone crushing and grinding, incomplete combustion, etc., human activities. In addition to above common pollutants, some specific pollutants such as chlorine, hydrocarbon, chlorofluorocarbon, pesticides, etc., are also ejected into the atmosphere from specific industrial units and industrial processes. The various air pollutants and the sources from which they originate are given in Table 1. Table 1. We shall now discuss at length the adverse effect of various pollutants, the maximum limit of their tolerance, and methods of their detection and control. Carbon monoxide. As mentioned above, carbon monoxide originates from incomplete combustion of carbonaceous matter in automobile engines and defective furnaces, incomplete combustion of agricultural and slash matter, and also by the interaction of carbon dioxide with coke at high temperature in industrial furnaces such as blast furnaces. Some natural processes such as forest fire, volcanic activity, seed germination, lightning discharge during thunderstorm, etc. also release carbon monoxide in small amount. Major proportion of the gas is of course contributed by human activity. Thus, of the total amount of CO present in the atmosphere, about 73% is contributed by vehicular exhausts and about 17% by forest fires and agricultural and slash burning. Industrial processes involved in steel, paper, and petroleum industries contribute about 9.5% of CO. The contribution by natural phenomena is thus very small. Although considerable amount of CO is being emitted continuously by human activity, its concentration in the atmosphere does not increase to any significant extent. This is because some factors operate in nature which eliminate carbon monoxide. Recent searches have shown that soil is capable of removing large amounts of CO from the atmosphere by virtue of their action of some soil microorganisms. Technically, the elements or organisms which consume a pollutant are known as sink. The soil microorganisms act as a sink for CO. In thickly populated or urban areas, the concentration of CO is considerably high because of heavy vehicular traffic and insufficient availability of soil to act as sink. On the countryside, the concentration of the gas is comparatively small. Toxic effects of carbon monoxide. The toxic effects of CO on human beings and animals arise from its reversible combination with hemoglobin present in the red blood cells of the blood to form Hb.CO. Normally, hemoglobin of the blood combines with oxygen of the atmosphere present in the lungs to form oxyhemoglobin Hb.O2, which undergoes dissociation to release the oxygen to the body muscles. Thus, Hb.O2 acts as an oxygen carrier for blood. Since Hb has much greater affinity for CO than for O2, the hemoglobin is more readily attacked by CO to form Hb.CO as shown above. The combination of hemoglobin with CO inhibits its oxygen carrying capacity in the blood, thereby reducing the availability of oxygen for the body cells, resulting in anoxia, oxygen starvation. Hb contains 5 coordinated Fe2 atoms. The 6th coordination site of each of these Fe2 atoms is unoccupied. The molecular oxygen atoms, the molecular oxygen atoms present in the lungs adds to the Fe2 atoms through the 6th coordination site and gets detached easily at the cell of the muscles. If instead of O2, the stronger CO ligand occupies the 6th coordination site of the metal atom, Hb would not be able to take up O2 from the lungs and deliver it to the body cells. The maximum permissible concentration of CO in the atmosphere is 40 ppm for an exposure of 8 hours. If the concentration is higher or the exposure is longer, adverse effect starts. There is some medical evidence that even as low as a concentration as 10 ppm of CO in the atmosphere may produce increased mortality among guest hospitalized heart patients. The higher rate of heart disease in smokers is also believed to be due to CO, which the smoker inhales from the cigarette smoke. It has been estimated that a person who smokes a pack of cigarettes daily inhales smoke, which may raise the level of the blood hemoglobin.CO to about 5% or more. This results in impairment of mental performance, visual activity, and other body functions. The most effective treatment for CO poisoning is to confine the victim in a chamber having oxygen at 2 to 2.5 atmospheric pressure. This accelerates elimination of carbon monoxide from the hemoglobin. Hb.CO plus O2 reversibly changes to Hb.O2 plus CO. Exposure to oxygen under high pressure also corrects anoxia by making available large amount of dissolved oxygen for blood directly, thus enabling the body to bypass the uptake of oxygen through hemoglobin. Thank you. That's all from this chapter from my side.